Hello, Matt G4IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 39, which reads: cross modulation is an effect that occurs when A. the receiver has inadequate rejection on its image frequency, B. strong RF signals enter the RF stage of a receiver causing non-linearity, B. both the wanted signal and the local oscillator signal are modulated, or D. different signals are present on the two sidebands of an AM transmission. So if we flip over to the full license manual, there is a section in the EMC chapter here called Overloading, Intermodulation, Cross-Modulation and Blocking, and this describes a set of effects that can happen when an unwanted strong signal gets into your receiver and effectively starts interfering with what you're trying to listen to. So overloading and cross-modulation are two effects that can impact preamplifiers and sensitive receivers in particular. And overloading is the result of a very strong signal. It may be sort of off frequency from something you're trying to listen to, or it may be on a completely different band altogether, and that could get into your receiver, maybe because there's poor filtering in front of devices in your receiver, and it causes those devices to be driven outside of their linear region. And of course the linear region is the zone where these devices operate, where they will faithfully reproduce their input. You know, you may have an amplifier that, when operating in its linear region, will amplify that signal perfectly and will add no distortion, but you push it outside of its linear region and it's going to start causing distortion, which adds harmonics to what you're trying to listen to. And this can happen just because there is a very strong signal, not necessarily the one that you're trying to listen to, but a strong signal getting into your receiver, and you're maybe turning up the gain on your receiver so you can hear that weak wanted signal, but that as a result pushes the devices in the receiver outside of their linear region and adds all kinds of distortion and harmonics to what you're trying to listen to. So cross-modulation is kind of a similar effect where you have a strong RF signal entering a stage in a receiver, and maybe it's not pushing it all the way out of the linear region and into full distortion, but it's perhaps pushing it outside of its linear region where the characteristic gain of that stage of the receiver is no longer predictable, or maybe pushing it outside of that linear region causes the gain to increase or reduce somehow. And that, of course, is going to happen as the amplitude of that unwanted signal varies. It's going to push that device out of linearity and perhaps change the gain characteristic. And what you end up with is this cross-modulation effect, where the signal that you're trying to listen to is being modulated. Its amplitude is being changed by that unwanted signal. So you get this effect of the wanted signal becoming quite fluttery and varying in gain, because the unwanted signal is basically changing the volume level of the wanted signal because of this cross-modulation effect. One of the giveaways of this happening is that the interference kind of comes and goes as the unwanted signal peaks, and on analog it can actually be, on analog signals it can be heard as sound, but with digital signals it would sort of be a momentary loss of signal, or momentary sort of scrambling of a frame of a TV picture, for example. So if we head back to the answers, take a look what sticks. Is it going to be because the receiver has inadequate rejection on its image frequency? Well, it kind of is the result of inadequate rejection, but it's nothing to do with the image frequency. That's something else entirely, so we can scrub that out. Option B, strong RF signals enter the RF stage of a receiver causing non-linearity, and that is pretty much exactly what we've described for both cross-modulation and overloading. C, both the wanted signal and the local oscillator signal are modulated. No, that's not what we described. Or D, different signals are present on the two sidebands of an AM transmission. And no, this isn't something that's limited just to AM transmissions. So let's go and check the answers, see if we've got that one right. And of course for 39 is of course option B. It is the result of strong RF signals entering the receiver and causing non-linearity. Thank you very much. I'll catch you for the next one.